All right, we are getting ready for the short Unit 5.1 quiz. Number 1, what kind of calculations would you use the heat of fusion or the heat of vaporization constants for? So, for the heat of fusion, delta H fusion, you would use that for a calculation where you wanted to find out how much energy it took to melt a certain amount of moles of something, or if you wanted to find the energy that needed to be released in order for a substance to freeze. And the heat of vaporization you would use if you wanted to calculate how much energy per mole would be required to boil a substance, or how much energy per mole would need to be released by a substance in order for it to condense, go from a gas back to a liquid. What happens to particles during a phase change versus a temperature change? Let's start with temperature change because it's a little bit easier. When the temperature is changing, the kinetic energy, the speed of the particles, is either increasing if you're adding energy, or it's decreasing if it's releasing energy. So it's all about how fast the particles are moving. During a phase change, particles' potential energy is changing. That's the distance between the molecules. It's either increasing, the particles are getting further apart, or decreasing if the particles are releasing energy and they're getting closer together. We're going to be putting all this together in number 3. Draw a cooling curve. It says you've got a gas at 108 degrees Celsius. So I'm going to label the top of this 108. This is temperature in degrees Celsius. The lowest we're going to go is minus 15. So this is water. So water, as it cools down from 108, particles slow down, but then it plateaus at 100 degrees. It flatlines. That's because that's the temperature where it takes extra energy, or it needs to release extra energy for the particles to come closer together. Now it's a liquid and it cools down until it hits 0 degrees Celsius when it plateaus again, because now it's freezing. Particles are getting closer together, and then it cools down as a solid. So the points where the potential energy is decreasing are the plateaus. I always think potential plateau, P and P. The parts where the kinetic energy is decreasing is any part where you see a slowing down of particles. The temperature is dropping. So these 3 slanted areas. Point out where here's the freezing point, which by the way is the same as the melting point if this were in the opposite direction. So it's 0 degrees Celsius, something will freeze or melt depending on if you're adding or taking away energy. And this is the condensation point here, which is also the same as the boiling point. Label the states of matter present. So way up here, when it's hotter than 100 degrees, it's a gas. And then on this plateau, it's both a gas and a liquid. Then it cools down as a liquid. And then this other plateau is both a solid and a liquid. And then it all becomes a solid. Number 4. A sample of iron was dropped into 20 grams of water at 20 degrees Celsius. If the final temperature of the water was 27 degrees Celsius, how much energy was transferred from the iron to the water? So the key thing here is we're talking about the energy of the water. So we're going to do the mass of the water times the specific heat for water times the change in temperature to calculate how much energy it absorbed from that iron. Must have been hot iron. Mass of the water, 20 grams. Specific heat of water, 4.18 joules per gram degrees Celsius. And what was the change in temperature of the water? It was 27 to 20, 20 to 27. So that's a change in temperature of 7 degrees Celsius. Grams cancels out, degrees Celsius cancels out. We're going to be left with joules. And this comes out to be, oops, got to do this on my Google calculator really quickly because I had it incorrect. So let's just go to Google. This is what you guys should do in a bind. 20 times 4.18, 83.6 times 7, answer 585.2 joules. All right, last question. It's a long one. How much energy does it take for 50 grams of water to go from 15 degrees Celsius to steam at 105? Let's go off to the side and figure out how many equations we're going to need. We're starting at 15 degrees Celsius. Water is a liquid. And it's going to heat up until it hits 100 degrees Celsius. Then there's going to be a plateau as it boils. Then it's going to heat up till the problem asks us to go to 105 degrees Celsius. So we've got 3 lines here. That means we're going to need 3 equations. First one, as we go from 15 degrees Celsius up to 100 degrees Celsius. Then as we go from 100 degrees Celsius as a liquid to 100 degrees Celsius as a gas. And finally, 100 degrees Celsius to 105 degrees Celsius. When there is a change in temperature, we get to use Q equals MCAT. Here it's a liquid, so I labeled it Cl. For boiling, you use the heat of vaporization, just like we were talking about in number 1, times how many moles, because this constant is in joules per mole. And finally, another temperature change, Q equals MCAT, but the specific heat for water in its gas phase. Now we need to plug the numbers in. Mass is 50, specific heat for water is 4.18, change in temperature from 15 to 100, 100 minus 15 is 85 degrees Celsius. So just to get up this first little slant right here, it is going to be 17,765 joules. 1/3 done. The heat of vaporization for water is 40,700 joules per mole. That's from your green sheet. Crap, we have to get 50 grams of H2O into moles. So divide by the molar mass, 18.02 grams in 1 mole of water. We are talking about 2.77 moles. So I'm going to plug that into my equation. 2.77 moles times 40,700, 112,739 joules. Finally, this last little bit, so if I'm drawing an arrow, that's for the plateau. Mass is still 50. Specific heat for a gas is 1.86. And the change in temperature from 100 to 105 is just 5. Multiply those together, I get 465 joules. So that's how much energy it takes to get up that last little bit. Now to find the total energy, I just add those 3 numbers and I get something like 130,969 joules. And then I'm done. Alright, good luck studying. Those are the kind of questions that you'll need to be able to answer, and study your skeleton notes to help you for this quiz.